Okay. Hello, everybody. My name is Morgan. I am an AmeriCorps member with the Conservation Nebraska Common Ground Program. I'd like to thank everybody for coming tonight as we have people filtering in to the webinar, just go over a few things from everyone. Your cameras and microphones will be turned off. So um, we can have full attention to our three wonderful speakers this evening. We do have a Q&A box and a chat box for some questions. I do ask that you just put those in as we're going through each presentation, and we certainly hope to have some time at the end to go over a few of those. And we also, towards the end of the webinar, will launch a short poll. If you could fill those questions out, it just gives us the opportunity to know what we're doing well and to keep continuing to do these educational events that we love to put on. So with that, we do have three speakers tonight, so welcome everybody. I will go ahead and present everybody and then they will take turns doing their presentation. So I will start off with Meredith Sutton. Meredith is currently pursuing a PhD in civil engineering with a specialization in environmental engineering. Their research explores the presence of microplastic contamination in agricultural watersheds and the impact of microplastics on the movement of nitrogen in constructed wetland environments. They are also involved in working to expand community engagement and water quality sampling through the Citizen Science Sue Well Community Water Project. In 2022, Meredith received their Master's in Environmental Engineering from UNL. Before coming to Nebraska, they earned their BS in Civil Engineering with a specialization in Environmental and Water Resources from the University of Virginia. Meredith is an NSF GRFP recipient, a part of the AGU Voices for Science program, and a National Academy's Mersenne Science and Technology Policy Fellow. We also have with us tonight Nirupam Aich, and they are an associate professor of environmental engineering at UNL, and his group is working on the PFAS pollution problem. And thirdly, we have Moriah Brown, originally from Knoxville, Tennessee, and she has received her bachelor's degree in civil engineering from Howard University. She just recently graduated with her master's in civil engineering from the University of Nebraska-Lincoln this past May and will be continuing with her PhD. Moriah's research is currently focused on watershed monitoring the Shell Creek watershed for antibiotics and antibiotic-resistant bacteria. And she also does some work with microplastics as well. So with that being said, I will hand it over to our speakers. They will each go ahead and give us some presentations, and please ask away questions. I will read those at the end and we'll have some time. So I thank everybody for being here tonight.
Thank you, Morgan. Thank you very much for inviting, and thank you, Meredith, for making the connection to the community. Yeah, so we decided that I will go first, or probably I decided that I'll go first. So Morgan, can we have access to screen share?
Yes.
You guys should be able to screen share now.
Okay, sounds good. Oh, okay. Can you see my screen?
Yes.
Okay, so Morgan already introduced me, so I'm not going to go along that line, but I wanted to say where I am from. I'm originally from Bangladesh. I grew up there. It's a country with double the 60 times less land than US, but 2 times or half the size of the population of US. So it's a very densely populated country. I did my chemical engineering degree there in bachelor's, and then I moved to University of South Carolina to do my master's in environmental engineering, then PhD from University of Texas, Austin. Then I was a faculty member at University at Buffalo for 7 years. I also partly resided in Florida. So I have been all over the place in US, except for West Coast, but before moving to Nebraska. So, and we were talking about weather, which is this year very mild in summer, which is great. And this is my lab group. Obviously not. So these are pets that I have, and my wife and I used to foster some of them. So this is one of the hobby. But what I have a very engaging group of students who do a really good job in doing research in environmental engineering field. At this moment, we have 4 PhD students in the group, but the work that we do and we have been doing over the past 8-9 years have been possible because of the contribution from these students. If you see, there are a lot of undergrad students, several master's students, and 2 PhD students who graduated. Okay. So, and we have been fortunate to be supported by several funding agencies for our research work that I'm going to talk about. They are funded by either National Institute of Health or USGS, US Geological Survey, National Science Foundation, all different agencies. Now, I don't know how much you know about this or whoever watched this movie, Dark Waters. If you didn't watch it, please watch it in Netflix. This has been out there from May 1st, I think, this year. And this is a 2019 movie that talks about the pollutant that I'm going to talk about, per and polyfluoroalkyl substances, or PFAS. In short, we talk PFAS, right? But they're known as forever chemicals. So the movie talks about a lawyer, environmental lawyer, back in Cincinnati, I believe, back in early 2000, who basically discovered that PFAS pollution, this chemical was being dumped by the company DuPont in an agricultural area in rural community back in West Virginia. And that story led to that unraveling of that story eventually led to identifying that this chemical class, or it's not one chemical, it's a lot of different chemicals that really is getting into our water and environment and causing health issues to humans and animals and organisms in environment. Okay, so please watch this. This talks about that. You will learn the true story that really unraveled that scenario. But what is PFAS? PFAS is actually the reason that we have a lot of great things and also the reason we have a lot of problems right now. So PFAS is a class of chemicals that have kind of a molecular structure like this, where you have a lot of carbon, but with all of the carbon are connected to fluorine molecules, fluorine atoms. So that's why polyfluoroalkyl substances. So carbon-fluorine bonds, carbon is kind of a positive charged molecule, and then atom fluorine is negative. So their bonding is very, very strong. So which worked really great because in 1940s, how it was starting that during World War, they needed to make tanks um, that can withstand water, right? No rusting should happen. So they created a coating, and you have all used Teflon. You have all used probably all different sorts of like non-sticky pans, cookwares. You have used firefighting foams, fire extinguishing foams. All of these were possible because these chemicals were made. So the Teflon that we use for keeping water out. So anything water repellent kind of has this PFAS compound in it. And these are not only one compound, one chemical compound, there are more than 15,000 different PFAS chemicals that are being used commercially or that has been used commercially. Okay, this is the example of the most prominent one that has been banned, PFOA, or 8 carbon chain chemical. So the issue is that because these bonds are very strong, these chemicals are very strong, and they are stable at high heat, they can repel water, and that's why we use them, right? Think about non-sticky cooking pans. We use them because they can withstand the heat, right? High heat. We like non-sticky cook pans. But at the same time, the problem is that because they are very, very strong chemicals, when they are released in the environment, either after our use, we throw out these non-stick equipments, we use them for years and we peel off at some point, the coating gets peeled off, and that coating can get in the environment. Then when they manufacture this chemical, a lot of these chemicals can, from the manufacturing plant, can get released into water, wastewater systems. So all these are coming into our environment, they are getting into our bodies, they are getting into our food chain, and they can cause a lot of different issues in our body. They can cause issues in neurological development of a child. They can cause cancer. They can cause problems in reproduction systems. All these things. Okay, so it's been a really, really problematic chemical. So what US EPA did recently is that they came up with this regulation for six different PFASs, actually, like 1, 2, 3, 4, and then 5, and then a mixture. So 6 different PFAS, and they finalized maximum concentration level of these PFASs in drinking water. So our drinking water has some sort of PFAS that we are seeing in drinking water. The problem is there, the drinking water treatment systems that we have in place typically cannot take out these PFASs from water. So when we are drinking water, we might be exposed to PFAS. That can happen. That's not always happen. That doesn't always happen, but that can happen. So what US EPA is doing is they're setting up these regulations, and this happened in April this year. And they have also identified the first two, PFOA and PFOS, as toxic substances. What that means that anytime any compound, like anything that you use or we use, like for even say leather jacket or clothing or food packaging, they can have PFAS in them. But if they have PFOA or PFAS, they will be considered as a hazardous substance. They are not supposed to be there because PFAS and PFOA has been banned for many years, and they are not supposed to be used in any manufacturing of any type of consumer products. So they may not be there. The issue is that this PFAS and PFOA has been banned, but when I'm saying like different 15,000 different PFASs are out there, because when we ban something, right, then companies come up with a newer PFAS, which is not exactly the same, but has the similar properties. So which is good for business, and we are having replacement of PFAS, but the problem is they're also getting into the environment. So overall, this is EPA's first effort to solve this problem. The problem now, one is we need to remove them from drinking water, right? So one thing that is happening, that all of the water utilities across the country, public water systems, public like drinking water treatment plants, they have to monitor how much of this PFAS is in drinking water. But at the same time, they have to take initiative to upgrade their systems so that we can take out PFAS from the water. And that will cost more than $200 billion at a minimum, okay? So this is going to raise our probably water bill at some point, but this is something that we are dealing with in future. But this is a good thing. The good thing is that we are taking out initiatives. We are taking initiatives to take out PFAS. First, to monitor PFAS if there is PFAS in our drinking water or anything. But if we find them, we are also taking prevention or mitigation efforts there. The other thing to remember that PFAS is very, very small in quantity typically. So the problem is that it's difficult to identify them in water or environment. But at the same time, PFAS can move from one place to another. For example, when we use PFAS in different products, they can go out from our usage urban area to a municipal wastewater treatment plant, like they're being carried in water, wastewater with our sewage, all these things, they go to wastewater treatment plant. From there, PFAS can either go out to surface water, although there are treatment processes there, but many of the treatment processes don't necessarily act as well as we would want for PFAS, right? So many of them can go into drinking water, surface water, but many of the PFAS get inside biosolids, which is the residual solid from wastewater treatment plant. Now, the issue with Nebraska and similar states who rely heavily on agriculture, in many cases, these biosolids are used in agricultural farmlands. And that is a concern for PFAS, not only PFAS, that is a concern for many different things, but PFAS is also a major concern that is concerning farmers, and like they can get into food crop, they can get into animals, like cattle and beef through the crop grazing or like grass grazing. Something like that can happen. I'm not saying it's happening in Nebraska. I'm saying there is a possibility. Okay. So our goal is not to say that it's happening already and why we aren't taking initiative. I think everyone is trying to look at that, because sometimes we think we don't want to be panicking, because it's not like they're killing like poison like everything, but we should be concerned about them. But we need to also be careful about how we characterize if something is really toxic or not. Okay. So I'm just trying to make this conversation in a way that we don't assume that, oh, everything is bad and everything is going bad. Okay. I'm saying there is a concern that this thing can happen. The other thing can happen, that PFAS from there, when they're used in farmlands, they can also leach after rainwater, rain events, on storm events. They can either leach to groundwater, they can leach to surface water. So all of these things, what I'm trying to say is PFAS can be anywhere and everywhere. Okay. One of the major sites that I haven't talked about, that because they were used a lot in, PFAS has been used a lot in firefighting events. So airports, army facilities, defense facilities, Army Navy, they used a lot of explosive, and that's why they used a lot of firefighting foams. So that's another place that many of the PFAS contamination has happened. So Department of Defense and others are actively trying to address those issues as much as possible and trying to remove PFAS from water or soil, whatever there is. Okay. So this is a thing on progress. So as I said, like PFAS can move from municipal wastewater to farmlands. There is a possibility, and then they can move from soil to the plant crop. We don't know how much, if this is going to be a problem, but there is a concern that we need to be careful about. If they go into crop, if they go into grass, where they're like we have kettles grazing them, all these things, they can also go into the food like milk, right? So these things can happen, right? And the other part is a lot of food packaging. So anything where we want nothing to get stuck, right? If we think about all the food packaging, we want the food in a pristine form, but we want the packaging to be nice and not mixed up with water or anything, like it's not wet or something like that. In many cases, food packaging use PFAS. For example, we always talk about we should get rid of plastic straws or plastic packaging. And then we come up with paper packaging, which are really nice, recycled paper and recycled or paper products, right? Paper cups from Starbucks or anything, right? We are really happy about it. But the issue is that these paper products, to be effective, to not get wet, right? They use PFAS in them. So now there has been a lot of discussions, like Starbucks and many other companies are pledging that they are not going to use any type of PFAS in their food packaging system. Okay, so these movements are happening too as we speak. So now we need to take out PFAS from our products, but we also need to take out PFAS from our drinking water. So a lot of things are going on to find out what current technologies are there already that are inexpensive, that has been used for taking out other pollutants from water. But also we are trying to develop new materials that can take out PFAS from water. Because with PFAS, there are two problems. One is, okay, we can have a technology like many of you may have think about filter using Brita filter or something like that. So Brita filter or something like granular activated carbon, you can use them where they can be used to take out PFAS from water. So these molecules can get absorbed or filtered out in the filter. Now the problem is that filter has the PFAS. You have to throw out that filter, but now you just concentrated a lot of PFAS in that filter. Now, how do we dispose them? That's a concern. So eventually our goal is to break down the PFAS molecule. So there is a lot of work that is going on. Can we take these filters that already absorbed separated PFAS from water? Can we take them and do something so that we can degrade the PFAS molecular structure? That way we can get rid of the toxic influences. Okay. So on that angle, what we are doing, my group actually works on nanomaterials and nanotechnology. And if you don't know what nanotechnology is, I'll give you an example. All the electronics that we are now using, like smartphone, these were not like that many years ago, right? If we think about 15, 20 years ago, we had a phone, a television, large, like humongous sized television. The computers were very, very large. Now we can do every single thing in a phone, right? We can do call, we can watch movies, everything. So everything is possible because everything got small, and that is because we are using now smaller materials or small size materials or nanomaterials to do those things inside a computer chip or smartphone chip. Okay, so we have like now very small things, right? So we use these nanomaterials to make and use we are using in one project, we have multiple different projects where we are using nanomaterials to come up with new filters that can take out PFAS from water. So one of this project is, can we 3D print nanomaterials to create a porous filter that can take out PFAS from water? So you have a nanomaterial that can create this porous filter, and then you flow dirty water through it to get clean water. We are trying to do that. So one thing is, can we absorb this PFAS on this filter surface, or can we make these filters in a way that they will not only capture the PFAS, but also will destroy by reactions that are happening on the filter surface. Okay, so this is one of the projects that we are doing. But in UNL, not only me, there are several other faculties who are working on different projects. And we are collaborating with Dr. Shuli. We are working on looking at how PFAS in a rain event can get released from agricultural land to agricultural watershed. Can they go into river or lake? And can they get released from products that we are using as a fertilizer? And then can we look at how they're impacting the environment there? Okay. Similar thing, Dr. Shannon Bartel Hunt, she's working on something similar to that. She's also looking at how much PFAS is there in different wastewater systems for different communities. Dr. Bruce Dvorak is a water treatment person too. He's a senior faculty. He's concerned about how rural communities, smaller communities, how will they address PFAS pollution issue if they have any issue. We are trying to build up something called Great Plains PFAS Initiative. We know that this is a major issue. This is going to be a major issue for not only for Nebraska, but also from North Dakota to Texas. All these Great Plains communities will have similar issues that are not being yet addressed by the current situation, right? We are actually planning a workshop here at UNL that will happen on September 5th, and we will have a session in the morning that might be open to the public or general audience, where we will bring in researchers from different universities, US EPA, then some industries and utility partners to talk about what issues they see along the PFAS discussions in coming future on how we can address it. Okay. So, and this is a huge problem. So we are not only thinking about solving it by ourselves, but we also want to partner with communities who are getting affected or who we think will be affected by this partnership between regulatory authorities and wastewater utilities. So we are trying to do that. If you are concerned about what to do in case of in case of a PFAS issue, I have this link open. So you can go to UNL. If you just search PFAS in Nebraska, this UNL Water INR, they have a page here that is updated in Wednesday, March 20. They are talking about PFAS facts related to drinking water. And if you go here, you will see that occurrence of PFAS in Nebraska's water. There has been testing from 2013 to 15, which didn't find any PFAS in drinking water in most of the places in Nebraska. But recently, some work has been going on where they are possibly finding few cases, but you can get more information. The testing is still going on. Like Nebraska Department of Energy and Environment, they are trying to monitor as much as possible in every county and every place there are. They are trying to monitor the drinking water quality. They are also collecting some surface water, well water, something like that. But you can also, if you are concerned about PFAS in your area or in your home, you can also do private testing. So there are testing like facilities across the country. You can also, like we also have UNL Water Science Lab. They also do testing for PFAS. And there is Nebraska Department of Health. They also have a lab that does PFAS testing. We are also getting a new instrument to start doing PFAS testing ourselves. But you can also like reach out to these companies that do testing if you are concerned about that. But there are some options. If you find PFAS in your water, it's not super concerning. There are different levels. And if you are concerned, you can look into the options, how to mitigate that. There are some technologies that can be used to mitigate that. So please go to this page. This is a very informative page. And if you have more questions, please reach out to us or UNL like folks that I've been talking about. So honestly, that's it. Thank you for listening, and I'll be happy to answer any question that comes later. And this is my group. We sometimes have fun, not only work. That's what I wanted to say. Thank you.
Thank you. We do have a question pertaining, Aiden is asking, are Teflon pans releasing these chemicals as we cook our food with the pans as well?
That's a great question. Thank you, Aiden. Here is what I have learned and I have understood. First, don't cook until you are taking pills. Many times we keep cooking in the same way for like 10, 15 years. And it goes, you are taking the coating off. Don't do it like that. But as we are cooking, we are not releasing anything immediately. Okay. But here is my suggestion. And I have talked with many people. I think if possible, don't use coated pans anymore. Or if you are concerned, there are now new cooking pans coming out that say PFAS free, or at least PFOA free cooking pans. They might be a little bit more expensive, but nowadays, if you go to the markets, you can find something like that. But I know that many people are moving into cast iron. Yes, there are different concerns about that too, but they're moving away from coated ones to make sure that there is no concern. Yes, many like regular ones, it may not do as much damage as we think, as we are concerned about day-to-day activities, but you never know. So I would just caution in that. Like if you can find other ones, that might be useful. Yeah.
Thank
Any
you.
other question?
Yes, excuse me. Michelle is also asking, what filtration system do you use and what are your thoughts on bottled water safety?
That's a great question too. So filtration, so if you go into different websites like Brita Filters, they are testing many different devices that they now you can find if you just search in Amazon and other places, you can actually find some companies that are selling PFAS, like filters for PFAS. Okay. They are possibly using granular activated carbon, which is and the link that I was talking about, UNL water, they are also talking about granular activated carbon. So Brita filters the newer ones, new generation ones, you can find Brita filters or similar other filters from different companies that have granular activated carbon can be very effective in taking out PFAS if you are concerned about it. The other thing is that if you have in your house reverse osmosis systems, that's obviously a great thing, but not everyone has it and it's expensive in many cases. So, but it can be another option. Reverse osmosis is very good in taking out almost any chemical from water. So that might be the other option. Yeah. But there are a lot of new options coming out. Yeah.
Thank you.
Right.
We do have another question. Lynette is asking, she joined a little late. What have PFAS caused/created health-wise in people?
Yes, there has been reports of the West Virginia situation. There has been a lot of epidemiological study in West Virginia, and then Chesapeake Bay area and North Carolina, three main areas. And these are the three I remember. There has been a lot of work on toxic like cancer, different types of cancer, and many of them are related to reproductive systems. There has been a lot of studies that show thyroid cancer. They're linked to PFAS. That's a major concern. For babies, there can be developmental disorders. There has been, so if you watch the movie Dark Waters, you will see a baby having face deformity, but that is due to more likely not like this type of contamination. That was more like from a person who was working in an industry that make PFAS. Okay, so that's a very high dosage, right? From drinking water or like from chronic exposure that we see in this case, the idea is that this can, in long term, this can cause cancer, different types. We don't know exactly which one, how immune compromised a person is, the effect will depend on that. But here is my point. You can consider PFAS as the new lead, okay? Because if you look at if US EPS maximum concentration limit goal, the maximum concentration limit is now 0.4 parts per trillion, which is honestly very, 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 very small to amount. Okay. But their goal is 0. What that means that you don't want any PFAS exposure. That's the bottom line. So it doesn't matter exactly what we are gonna get. The thing is that we don't want any exposure from PFAS, just like we don't want any exposure from lead. It's as simple as that. Okay.
Wonderful. Thank you very much.
Yeah. Okay. So I'll take off. I mean, not take off. I'll be quiet and then Meredith and Moriah.
Yeah, I'm gonna take over after your talk.
Yeah.
So
Sure.
There we go. Can everyone see it? Good. Okay, well, hi everyone. Again, my name is Meredith Sutton, taking over after Nirupam. And so I'm going to be talking about microplastics in the environment. So most of my research looks at microplastics in agricultural environments. And just a little bit of background, I'm currently a grad student working on my PhD with the Environmental Quality and Communities Lab. So me and Moriah are actually from the same lab group in the same department as Nirupam. So just a little background on microplastics. So microplastics are essentially just plastic particles that are smaller than 5 millimeters. So if you think about that, 5 millimeters, you can actually see that with your eye. And then the lower kind of limit goes down to nanoplastics, which starts at 1 micrometer, 1 micron, which is very, very small. And so when we're looking at microplastics in the environment, we often kind of sort them by size, shape, and color. And so on the left, you can see some examples of common shapes and chemical compositions that we look for. And so some common ones are fragments, which you can see in A, films, and B, which if you think about like plastic bags, that's kind of what we're talking about here. And then fibers and C, and so that kind of, if you think about synthetic clothing, that's what we're looking at there. Also, when we're talking about microplastics, we split them up commonly into primary and secondary microplastics, where primary microplastics are microplastics that are manufactured at that really small size range. So these can be things like microbeads and personal care products or industrial scrubbers. And then secondary microplastics are plastics that are degraded in the environment. So this is what we often think of when we think of microplastics, where we have larger pieces of plastics that have been exposed to like weather and water and different conditions and have broken down into bitsy pieces. So this is just a fun little kind of schematic talking about all of the sources that we're kind of looking at and considering for microplastics in the environment. We find that microplastics, much like PFAS, are coming from a lot of different industries, but most notably kind of urban environments and agricultural environments. So we see input into the environment from wastewater treatment plants, where like textiles, if you're washing your clothes and they're synthetic, they will shed microplastics and they end up in wastewater treatment plants, and other personal care products will as well. Then we get runoff in urban areas from tires from the road and other kind of waste products there. And then in agricultural environments, we're also seeing a pretty high concentration of microplastics leaving these and entering the environment as well. So they are kind of everywhere, but we are definitely trying to figure out where the highest sources of microplastics are coming from. So I'm going to focus on the agriculture environment just because, you know, that's my kind of research area and also very pertinent to us here in Nebraska. And so this schematic is kind of talking about kind of inputs of microplastics into the agricultural environment and then how they leave the agricultural environment. So we see microplastics showing up in different types of mulching films and compost. Microplastics are also entering through sewage sludge. So the biosolids that Nirupam was talking about with PFAS is also a really big issue with microplastics, because we found that a lot of microplastics that enter wastewater treatment plants aren't actually necessarily leaving the wastewater treatment plants and entering the environment, but they're getting collected in the sludge and getting concentrated there. So that could also be a pretty big issue. And additionally, there are some primary microplastics, to pull out that little vocab term again, in the agricultural environment that enter through different pesticides and fertilizers that are associated with plastics that are put on the agricultural environment directly. And so once these microplastics are in the agricultural environment, they start to break down because they're going to be exposed to sunlight and water and different techniques that are mechanically used to like move the soil. And so once they start to break down, they can then be moved from the agricultural environment either by wind, dust, so they become light enough that they can be picked up and moved through the air, or they might run off into surface water during a storm event, which is kind of the focus of our research. And they can also start to move vertically in the agricultural environment down through the different soil layers and end up in groundwater. So kind of onto our work. Our work is focused specifically on looking at some of the sources of microplastics in the agricultural environment and how they end up in surrounding waterways and what those concentrations kind of look like for Nebraska. So we really want to look at their trends and like shape and size in relation to watershed characteristics. So how agricultural the watershed is, if there's any like large point sources that we should be considering. So things like wastewater treatment plants that are discharging directly into that river. And we have 2 projects currently going on that kind of look at these aspects. So we just finished up a project recently that is looking at the transport of microplastics from agricultural fields that have been applied with biosolids. So looking at how those concentrated sources of microplastics in the biosolids are moving from the agricultural fields into the surrounding environment. And then we have a field sampling project that's looking at several different watersheds across eastern Nebraska and looking at microplastic concentrations in both the water and the soil. And you can see some of our wonderful undergrads in the pictures on the right sampling for those. They go out every summer and fall to do that, and it's a lot of work, so we're very grateful for them doing that. And then just to give you a little bit of background on kind of the methods that we're using to look at these plastics. We mostly take grab samples of water, soil, and sediment. So these are just small samples in containers that we take back to the lab from the field sites to analyze. And these samples, we oxidize them and then use density separation to take the plastics out. So basically we make sure that there's no material stuck to the plastics through oxidation. And then you basically try to float the plastics out of the kind of like sediment matrix so that we can collect them and then visually identify those plastics. So I'm going to talk a little bit about the 2 projects that I mentioned. So this is the project looking at agricultural soil amendments, focusing on biosolids. So in the picture on the left, you can see kind of the way we set up our field experiment. We were comparing fields that were applied with biosolids with control fields, and then fields that were applied with manure. And we would collect the runoff from these plots into a collection tank and then look at the microplastics that ran off and the microplastics that were still sequestered in the biosolids. And we did find that biosolids can contribute microplastics to the environment at significant amounts. So they are moving from those fields where they're applied into the environment. We then modeled these rates to estimate the release of microplastics in corn and soybean production areas. So you can see in the graph of Nebraska below, the areas that are darker are at higher risk of transporting of microplastics leaving these areas where biosolids might be applied and ending up in waterways. And we found that for Nebraska that each year 5.2 billion microplastic particles are estimated to be released from these areas. So this research was mostly done by a contemporary of mine, but I did get to help a little bit with it, and it was very interesting to see how microplastics might be leaving these agricultural environments. So now with our watershed sampling program, we are looking at 4 different watersheds that you can see them like lightly highlighted in different colors in the map at the top on the left. And those correspond with the different creeks on the right, the sampling points that are color coded. Yes, that's the word. So they're color coded to correspond. And each of these watersheds we picked specifically for different characteristics. So you can see how Elkhorn has a wastewater treatment plant that is within the sampling parameters. If you look on the top right, between the Shannon Lane and Fremont Outfall sampling sites, so we can look at the influence of microplastics entering there. Salt Creek goes through Lincoln, so we get an urban influence there. And then Johnson Creek and Big Blue kind of mirror each other, but with drastic size differences. Johnson Creek is a creek, it's very small and contained within Salt Creek. And then Big Blue is much larger. However, if you look towards the bottom at the pie chart, you can see what the land use for these areas are. And you can see that cultivated crops are the majority for all of them. We obviously are a very heavily agricultural state, but Johnson Creek and Big Blue do have a similar proportion and have the highest level of agriculture. Excuse me. So these 2 charts show some of our preliminary results for the 2021 sampling season. And so you can see the microplastic concentration and microplastic particle per liter on the left. And then as it goes across the bottom, it has our different watersheds with each of the sampling points, and each of them are going downstream for each of those watersheds. And so some interesting things to note, in the top part looks at water samples, and the bottom part looks at sediment samples. And some interesting things to note, in the Elkhorn River, you can see that there is a expected sharp spike in microplastic concentration released after the wastewater treatment plant outfall, which decreases later on, which we were kind of expecting because wastewater treatment plants are a point source for microplastics. And then if you look at Johnson Creek and Big Blue in comparison, for both the water and sediment samples, you can see that Big Blue seems to have a higher concentration than Johnson Creek in its water, but that isn't necessarily the same in the sediment. And this is kind of looking at some of the watershed characteristics, right? Johnson Creek is much smaller and it's much slower moving, so it allows for a lot of microplastics to settle out into their sediment. And it's also much more of a clay-like consistency for the riverbed. Whereas Big Blue is much larger, much faster moving. Plastics are going to most likely be found more so in the water column than necessarily in the sediment. And the sediment in that area is a lot more gravelly, so it's much less likely to collect microplastics. In comparison of the sediment versus the water quality, you can see the light orange color is fibers, so harking all the way back to the beginning and morphology and shape, whereas the blue color are fragments. And you see that fragments are much more prevalent in our sediments as opposed to fibers, which are much more prevalent in the water samples. This is likely because fibers are lighter and more likely to stay suspended in the water column, whereas fragments are more likely to settle out. So that's an interesting kind of difference in morphology that we need to keep in mind when sampling for them. So some conclusions on this research is that biosolid amended soils can be a significant contributor of microplastics leaving agricultural areas. and that microplastics are prevalent in all of the agricultural waterways that we've sampled in Nebraska so far, and those concentrations are influenced by watershed characteristics. And going forward, we plan to increase sensitivity by focusing on one of the watersheds that we're working with, the Shell Creek watershed, which we've been doing some of the ARG research with that Moriah is going to talk with, to take more regular samples and focus more on like time dependency and weather dependency. Yeah, and so that's all I have. I'll be happy to answer any questions. And thank you all for listening to me talk about microplastics.
Thank you, Meredith.
Yeah.
We do. So I have a question here from Al. It says, the Nebraska sandhills are pristine, but most ranchers now bale hay using twine. Are there any studies being done in sandhills, lakes, and streams to assess the quantity of microplastics in those areas where there should really be negligible numbers?
Yeah, that's a really good question. And honestly, it's really interesting. One of my favorite things when doing presentations like this, especially in like agricultural environments, is someone will always hit me with a like, oh, they're doing this now with this sort of thing that's plastic or synthetic. Have you considered it? And most of the time the question is, no, we haven't necessarily yet. I don't know of anyone else doing any sort of microplastic study in the sandhills region. But that's definitely something that we can take into consideration going forward to look at. One of the one of the difficulties with microplastics is not only are they, moved by like water terrestrially, but they are also, especially fibers, very easily moved through the air as well. So even areas where we're finding that, it should be pristine, right? Like there's nothing happening in that area that should be contributing microplastics, where we're still finding, especially fibers in those areas. Because they're, deposited by dust or rain or something like that. But yeah, that's definitely an interesting area to look into, and I'll definitely take a note of it. And if we start expanding our watersheds, look into that. Thank you.
Perfect. Thank you. Another question is from Aiden. Do we know why biosolids have a higher concentration of microsolids?
Yeah. So biosolids, they have a high concentration because they're actually doing their job of what they should be doing in wastewater treatment plants. Wastewater treatment plants, the idea is to remove all of these solids from the wastewater that's coming in so that it's clean once it leaves the wastewater treatment plant and enters the environment. So the fact that, biosolids have like a high concentration of microplastics is great, because it means those microplastics aren't necessarily leaving the wastewater treatment plant in the water, and they're being pulled out like they should be. We started trying to make use of biosolids because they are really nutrient heavy, and it seems like a waste, right, to like not be using this resource that we have. But unfortunately, even though, nutrients are being sequestered in these biosolids, a lot of other things are being sequestered as well, like PFAS and plastics and antibiotic-resistant things that Moriah will mention as well. So that's definitely a problem I think we need to work on a lot as kind of a whole across a lot of different disciplines, because it does seem a waste to not use that resource, but we do need to make sure we're using it responsibly.
Wonderful. Another question from Michelle. Are microplastics affecting the fish we catch in our lakes and rivers?
Yeah, so there's been a really long documented, specifically more so in the ocean, effect on fish and microplastics. Microplastics often will look like small macroinvertebrates that fish, especially smaller fish, like to eat. And they will consume them. And if the plastic is large enough that it can't easily pass through their digestive system, it will get stuck there, and it can eventually kill the fish, depending on how much they consume. This is a bit more of an issue, I think, sometimes in the ocean with plankton and things like that. But obviously there is the concern of bioaccumulation, right? Where like smaller fish will eat, a couple pieces of plastic, and then larger fish or birds will eat a lot of those smaller fish, and like a lot of plastic ends up in different animals. So it's definitely a concern. I don't necessarily think it's a concern for you eating the fish right now, because I don't think people generally eat like the intestinal tracts of fish. But like long-term health of, the different like lake environments, I think it definitely is a concern.
Thank you. And not so much a question, but more a comment to that first one you answered with the sand hills. And it just says, thanks, as you probably know, the twine is theoretically designed to break down, but that would deposit it all into the surroundings.
Yeah.
So I don't see any more questions at the moment. Thank you, Meredith.
Yeah, thanks so much.
Yeah, we can hand it over to Moriah and continue forward.
Yeah, so I'll go ahead and share my screen. All right, can everyone see my screen?
Yes.
So yeah, again, I'm Moriah Brown. I am from the same lab as Meredith. Also work on microplastics, but I'm going to be talking about another project that I work on. It's called Connecting Antimicrobial Resistance, Agricultural Decisions, and Environmental Systems, a tool for mitigating AMR and assessing risks to human health in agro ecosystems. And this project is focusing on looking at antibiotics and antibiotic-resistant bacteria in rural surface waters. So first I'm going to talk about like what is AMR. So antimicrobial resistance is what AMR stands for. It's sometimes called antibiotic resistance as well, but it's basically the same, talking about the same thing. So first I'm going to talk about what are germs and antimicrobials. So we know germs are very small living organisms, and that includes our bacteria, fungi, parasites, and viruses. And then we have antimicrobials, which includes antibiotics, antifungals, and other medications, and they are used to treat or prevent infections. And the bacteria, viruses, fungi, and parasites can cause those infections and other illnesses, and then they are treated with those antimicrobials. And how antimicrobial resistance happens, it's when those germs evolve over time and they no longer respond to the medications we are using to treat them. And so those resistant infections can become more difficult and sometimes impossible to treat, while a person or even an animal can not become antimicrobial resistant. The organism that is making them sick can become resistant. So the threat of antibiotic resistance in the United States. So this was a report put out by the CDC in 2019. This is the estimate that they gave that each year antibiotic resistant bacteria and fungi causes at least almost 3 million infections and just under 36,000 deaths, which is pretty concerning. That is the main reason why we're concerned about this, is because antibiotic resistance, antimicrobial resistance just make these infections harder to treat. It also is costly to create new medicines to treat these to replace the old medicines that don't work anymore. So the objectives of this project, there are 3 objectives. I mostly focus on the first objective of this project, and that is to characterize and predict AMR transport. So to do that, we do watershed monitoring. And so we're taking bi-weekly grab samples collected from 4 locations along Shell Creek, which is in like East Central Nebraska. And these samples are processed for those antibiotic-resistant bacteria, antibiotics, and ionophores. And ionophores are just another class of antibiotics that are specifically used in cattle. part of this objective also includes SWOT integration, and SWOT is the soil and water assessment tool. And this model will be used to develop a watershed scale model to predict the movement of the bacteria and genes through environmental pathways and ecosystems. So what we are finding in the watershed from our monitoring, we are going to use that data to build this model, and it hopefully will be able to predict how the bacteria and genes are moving through our watershed in the future. So for the second objective, it is to integrate our results into what we call camaraderies to assess the risk associated with AMR in agro-ecosystems. So one big thing about this antibiotic resistance issue is we don't know how the concentrations of bacteria in our surface water can cause risk to us later having antibiotic resistance. So as new knowledge is generated from our SWOT model, we want farmers and key stakeholders to incorporate that knowledge into their decision-making process. 3 aspects may affect the risk attributable to antibiotic-resistant genes, and that will be evaluated. So the first one is the likelihood of the gene being transferred to human bacteria. And the second is the probability of disseminating the gene through environmental exposure pathways. And the third is the severity of the public health problem. So the final objective is then to improve the knowledge of AMR-related risk among food producers. So that's our farmers, our cattle producers, swine producers as well. And so this first started with the I Am Responsible project. On the right is their Instagram and Twitter page if you want to follow them. And so the objective of the I Am Responsible project is to first increase nationwide capacity, develop a antibiotic resistant related educational content. So that's on their Twitter and Instagram. They are usually posting infographics. They also have a YouTube page, I believe, where they also are sharing antibiotic resistant related content. So facilitate the dissemination of research-based materials. Again, they're sharing, as I produce more results from the research that I'm doing currently, they would probably also share that with people through their website and their other social medias as well. And then effectively engage audiences of disparate backgrounds on shared responsibility of AMR. And lastly, to empower the behavioral changes among audience members to combat antibiotic resistance. And we also want to include an AMR summit and farmer engagement. So this AMR summit, the goal is to bring key stakeholders together to evaluate our project's results and initiate the development of an AMR action plan. And we want to gain consensus of future actions to address AMR. For farmer engagement, there's going to be a 15-minute outreach presentation that's going to tailor to increase the overall knowledge among farmers about antimicrobial resistance and how their production practices might impact environmental transmission of AMR. And this presentation will be shared at manure management trainings, and these are held across over 70 locations in Iowa and 10 locations in Nebraska. And this has the opportunity to reach more than 5,000 individuals in the livestock and manure industries. So that is basically all I have for this project. But to conclude, I also want to start to relate this to microplastics as well. So microplastics, one thing that Meredith didn't mention is that they can actually be a carrier for other contaminants. So they are also a very good carrier of antibiotics and antibiotic-resistant bacteria. So that is another thing that I want to look at as well in our watershed as we continue this research. Thank you.
Thank you, Moriah. Alrighty. So we do have a question from Michelle. How active on average are farmers concerned with these issues, and do they initiate action or inaction?
So from my experience, I'm not quite sure. I haven't actually been able to be in contact with the farmers themselves yet, based on my role, but it is understood that farmers know that they do treat animals with antibiotics, and that antibiotic is then released within their manure. And if they are applying manure in the field, that there is a chance of it running off into nearby streams, into the surface water. So there are best management practices that farmers usually incorporate onto their fields, whether that's putting buffer strips along water edges if they have any, or just trying not to use as many antibiotics as they used to. Yeah.
Perfect. And it's not necessarily a question, but more of a comment for everyone tonight, just from Peggy, that this has been very interesting, and thank you for being here. Looking forward to watching it again on YouTube. So, with that, if there are any more questions, please feel free to put those in there for Meredith or Moriah. And then Kat's also going to launch that poll for everybody who joined us this evening. If you don't mind just answering a few of those questions for us, it's really great. In regards to this evening, though, I appreciate everybody being here tonight. This was really great. And I am just really appreciative of your time. I really loved hearing about everybody, and I just can't thank you enough. So thank you again from me. And we will go ahead and send these out. Like I said, this recording will be on YouTube for later viewing purposes, and I plan to follow up with any of our attendees, and I will be sharing email addresses, and if there's any questions, we can reach back out to our presenters. So thank you very much.
Thank you so much for having us. This is really great.
Yeah, thank you everyone for listening.
Perfect. Oops. All right. With that, I don't see any more follow-up questions. If I do get anything, I will go ahead and forward those over. Otherwise, everybody have a wonderful evening. Thank you.